All right, by popular demand, I am going to talk about last week's example, but I'm going to create a very simple example that follows precisely with what we did last week and then walk you through it. So I created the same situation we had before. Let me see, I've run this several times, so I want to make sure I have the right coefficients. I do indeed. Okay, so you can see here that I have happy as my dependent variable. I have pet as my predictor. It has 4 levels, and I have mess that has 2 levels. And then I create my marginal means, which looks like this. So I have cat, dog, fish, pig, and I have -1 and 1 for mess and no mess. Okay? So these are the original codings, right? This is what it looks like for the nominal level variables. And what I want to do is walk you through how to calculate the intercept, the main effects, and the interactions. So the intercept is straightforward. You can see here. Here's the intercept, 0.5632. I won't worry about whether it's significant or not. It's more important just to get these. We're focused on the B's, and we're focused on how to calculate and interpret the B's with the marginal means. So the intercept, or B naught, is 0.56, and all we have to do is take the mean of all of the marginal means. That's this column right here. If you just take the mean of all of those, also known as the grand mean, and for many of you, if you were following in class, what I did is I showed you that the grand mean is an X with 2 bars over it as opposed to just 1. So you take all the cell means and you take the mean of all the cell means, and that's what you get, the intercept. Okay, now the main effects are pretty straightforward because what they are the observed effect that you care about minus the grand mean. So therefore, pet 1 is cat, because as you can see here, my contrasts, if I show you what my effects coding looks like, you'll see pig is my default comparison, and I have cat as my first. Pet 1 is cat, pet 2 is dog, and pet 3 is fish. So if I look at pet 1 has a -0.5, so that's the coefficient, that's the B for pet 1. Okay, how do we get that effect? How do we interpret that effect? Well, that effect is all of the cats, all of the cat means, so this, the first one, so it doesn't matter whether mess is -1 or 1. We take both cat for -1 and cat for 1. We take the mean of those two and we subtract out the grand mean. And what we get is, sure enough, when we calculate that, we get exactly what we expect, the B. So how do we interpret that? Well, that means that the mean of cat is, if we look in terms of this computation, and then we interpret the B, what we're saying is that the overall mean of cat is 0.5 lower than the grand mean. So cats make us less happy. We knew that from the beginning. So let's take a look at mess. Let's change our predictor, and you'll notice here that this is the way it was originally coded. That's this column right here. So the rows are labeled as -1 and 1. That's the original coding, just like this. These are the original codes: cat, dog, fish, pig. And up here, these are just how they're represented. So 1, 2, and 3 for my effects codes. And these are the actual effects codes that are used. Notice here that the effects codes are opposite. Why? Because I wanted you to realize that the rows are just nominal level values. So whether it's -1 or 1, you always have to pay attention to how things are coded. So I wrote here, whoa, the codes are reversed. So always remember Always check your contrasts. Okay, if we look at the main effective mass, the main effective mass is minus 1.27. You can see here, that's what it is. And I have my marginal means again. So how do we calculate that? Well, now instead of having all of our effects, we only had 2 cells to calculate, but now what we have to do is, because we have 4 levels of PET, we have to take the mean of 4 levels. Now, which 4 levels are we going to take? Well, these are the original codes. So group 2, these are the original codes. And remember that they're reversed. So my real number 1, my positive 1, is for negative ones. You can see here, my positive 1 is for all negative 1 values. Okay, so just imagine that minus 1 is no mess, and 1 is mess. So 1 stands for no mess. Okay, so how do we do this? We take the mean of all the no messes, and we subtract out the grand mean. So what does this say? If there is no mess, the effect is minus 1.27 or 1.3. So the no mess group, pets that make no mess, will be on average 1.3 points of happiness below the grand mean. So no mess will make happy lower. All right. Now comes the tricky part, the interaction. How do we want to calculate cat by no mess. I'm going to change this, make it capitalized. Why do we want to do that? Because that is what pet1 mess1 represents. And this value right here, 1.52, is a conditional statement that says these are cats that make no mess. So let's consider our effects. We have, these are our contrasts for pet, and this is our contrast for mess, excuse me. So I'm going to relabel these so that they make sense. And I have no mess and mess, just as I had said before. All right, now, this is the logic I talked about in class, where you have no mess and you have mess. And I like everybody to take a look at this so that you can see how these codes are actually computed. Now, how do we calculate or how do we compute the marginal mean? Well, it's pretty simple. You take the one mean for the cell that you care about. Okay, what is the cell that we care about? I'm going to go back to, whoops, where is this? Okay, I'm going to take a look at, and you can see I've relabeled this. I want the cat no mess. Now, why do I want cat no mess? Because remember that the interaction focuses on cats with no mess. That's this effect right here. This 1.52 is cats because pet 1 represents cats and mess 1 represents no mess. So I want cats with no mess. That's my y hat. So what I'm going to do is I'm going to calculate, I want to be able to put back in my equation that value. So this is how you calculate it, but let me just start out with the regression model and work backwards to show you how you get there. So remember that we have a very simple model. We have y equals cats plus dogs plus fish. Now, pigs turn out to be implicit in this model, and so we're not calculating pig explicitly. Pig is implicit in the model, and we can calculate what pig is by taking the grand mean and subtracting out all of the other coefficients. And you know about this already. So what I'm going to do is I'm expanding this. So I have cats, dogs, fish, no mess, and then the interactions. Cats by no mess, dogs by no mess, fish by no mess. All right. When we have a significant interaction for this interaction right here, cats by no mess, we need to think about the equation that we are using. So let's take a look at this. If you substitute zeros in, because cats with no mess, they're not going to be dogs and they're not going to be fish, so those turn into be zeros. No mess is going to be 1, so we need to keep that. And cat by no mess is going to be 1. We need to keep that. but dog by no mess and fish by no mess, well, they're going to be 0. And then B naught is the intercept, and I just labeled it here as intercept. So what's Y predicted? Y predicted is going to equal the cat main effect plus the no mess main effect plus the interaction plus the intercept. Now remember that Y predicted, whoops, I'm going to put that there. Y predicted is the cell mean for cats that make no mess. And that's this right here. That's the Y predicted. When you're making predictions on categorical variables, you're predicting what value would be observed in that cell. So Y predicted is the cell mean for cats that make no mess. We want to compute the coefficient for the means for this interaction right here. Cats that make no mess. Thus, by simple algebra, we say cats that make no mess equal Y predicted, right, minus the intercept, minus cat main effect, minus no mess. And if we use all of our computations from above, we see that cats that don't make any mess, that's that B for the interaction, equals our mean for cats with no mess minus our intercept minus our cat main effect minus our no mess main effect. Okay? If you look back at these marginal means, you'll see how to calculate that pretty easily. And when we calculate it, sure enough, we get exactly what we were expecting. So what's the moral of this story? When you calculate the main effects are deviations from the grand mean. But you'll also see that the interaction effects include the grand mean as well, but we also have to subtract out the main effects. Why? Because as we've talked about all along, that these are partials. And by partials, you need to think about all interactions being residualized effects. Residualized effects meaning that the main effects are always subtracted out. And therefore, when you think of partials, always think about taking out the effects that are due to all of the other effects that precede it. Okay? So now what we have is we have ways of testing interactions, main effects, and assessing the intercepts and assessing all of these B's by looking at the marginal means. And that's really the focus. That was the focus for week 7 and 8, is to exercise this, because the more you become familiar with this, the easier it is for you to use MRC as opposed to ANOVA, so that you don't have to do a lot of post hoc tests. You can do a priori contrasts. That's what effects codings are. Effects codes are contrasts that can be specified a priori to save statistical power, because as soon as you move to post hoc tests, you have to do protected t-tests, which will always deflate your statistical power and inflate type 2 errors. So that's the reason why we spent 2 weeks on this. And always go back to the original equation. Think about regression from the equation standpoint. It's pretty simple. You can stick in 1s and 0s and -1s pretty easily. And when you do that, you'll find that the computation of all of the B's as well as the recreation of the marginal means becomes fairly straightforward. All right, so that's a wrap up of week 7 and 8. From this point forward, we're going to advance to more complicated coding, and then we're going to wrap up all of chapter 8 after this week. So stay tuned for that.